Alright, and so we have one final example here, and we want to find the surface area for this function where we're restricting z to be between 0 and 1. Okay, great. But now, wait, we're not given a parameterization. So, okay, first thing we need to do is parameterize. We happen to see this one earlier in an earlier video, so the parameterization is kind of fresh in my mind at least. But the parameterization that we should use, x of, and then I'm going to use r comma theta. Okay, this parameterization should be r cosine theta, r sine theta using polar, and then r squared. Okay, and then we know that r is within 0 to 1, and we know that theta is within 0 to 2 pi. Okay, so then I'm going to do the same sort of procedure as before and find t of r, t of theta, cross them, find the length. Okay, t of r. Okay, doing this, I get cosine theta, sine theta, and then 2r. T of theta is going to be minus r sine theta, and then r cosine theta, and 0. Okay, and when I cross them, then I have to do the first parameter cross the second parameter. Okay, I end up getting negative 2r. I did this off paper, so 2r squared cosine theta, and then minus 2r squared sine theta, and then r. And now I need to find the length. tr cross t theta. And again, I did this off paper, so you might need to as well, or at least dedicate time and energy and space. R square root of 4r squared plus 1. Okay. So now I'm ready to find the surface area because I need to do the double integral of the length of this normal vector, standard normal vector. And so then this is going to be r squared of 4r squared plus 1, and then dr d theta. And when I put in the bounds, okay, I'm going to do 0 to 2 pi, 0 to 1, and then r 4r squared plus 1, and then dr d theta. And I'm going to tell you, I'm going to skip all the calculation and tell you, okay, to integrate r, you have to use a u substitution, and then theta is just multiplied by 2 pi essentially. And so what we end up getting is pi over 6, and then 5 to the 3 halves minus 1. Okay. So that should make our life easier by skipping a lot of calculation, but in the instance where you're finding, and this is a paraboloid, right? So that one you can't use elementary geometry to find, but we can use calculus to help us find the surface area. And so this formula is useful, as I promise, so just know that it may take you a while to do these calculations, and make sure to double check them with Wilhelm Alpha or another classmate, and you'll be well on your way.